Hello, ladies and gentlemen. This is Mr. Hunter, and this is the lesson on using trigonometry to find angles and sides for a right triangle. So far we've used Pythagorean's theorem to find the sides of a triangle, and that's when you have either the hypotenuse or one of the legs, or you have both the legs and you're trying to find the hypotenuse, or as we call it in physics, the resultant. You can use a squared plus b squared equals c squared to find the third side. But there are cases where, and soon we're going to encounter them, where we have two sides and we need to figure out the angle. Or we have an angle and a side, and we need to figure out the other side of the triangle. So in that question, well, what do we do to figure that out? Now, please feel free to stop and pause this video, go over different parts. That's why I do the videos, is so that you can go at your own pace. For some of you, this will be totally new because you are taking Algebra 2 Trig or you haven't. So I definitely recommend recording everything that I do here, as well as watching it a few times over, because we will use this concept throughout the entire year. It will never leave us. So in math and geometry, we have a triangle. And as you know, the inside angles of that triangle equal 180. And we also have the sides of that triangle. Now, in the case of physics, we have been dealing with vectors. So as we approach the vector treasure hunt lab, and even I've already had you do this, where you map the resultant of the courtyard or took the resultant of my room or the hypotenuse of the room, you ended up walking one direction, and then you ended up walking another direction, and then you found, so here's my start, here's my end, and you then basically used a squared plus b squared equals c squared to find that hypotenuse or result angle. But what if I asked you, hey, I want to know this angle? Now, just so you know, this sign is the Greek letter theta, and theta for math and physics means angle. So whenever you see that symbol, we're talking about an angle. So if I said, hey, find that angle, or hey, I have an angle and a side, I want you to find another side, this is where we use trigonometry. And for some of you, this will be review. For some, it's new. And we use what's called SOHCAHTOA. There's many acronyms that you can use to remember this. The one that I learned, that my math teacher taught me, was, because I grew up in the city, was some old hoe caught another hoe tripping on acid. It's not a very nice one, but I remembered it. Or another teacher taught it to us as in SOHCAHTOA is an Indian. So SOHCAHTOA stands for, you use the mathematical sine function, and then it is opposite, and then hypotenuse, and then ka is cosine. And then you use the adjacent side, which I'll show you in a second. And then hypotenuse. And you can spell it right there. And then we use tangent, which is the opposite side. Sorry, I'm running into this triangle. I didn't mean to do that. Okay, so that's what each of those things mean. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let me actually show you what I mean by those values. Okay, so here we have the triangle, and those adjacent, opposite, and hypotenuse are always relative to the angle that's there. Now, the thing about the hypotenuse, it is always directly across from the 90-degree angle, and will always be that. The opposite side is just like it sounds. It's exactly opposite of the angle. So it's that wall of the triangle that's always directly across from the angle, and adjacent is right next to. Hopefully you're like, duh, Mr. Hunter. But if not, that's how we know what side is what. So we look at our angle and say, okay, the opposite is relative to where the angle is. Because case in point, in this example right here, my opposite and adjacent would change if I drew this theta right here and said, hey, where's my opposite? Then technically, this would change to my opposite, and this would change to my adjacent if this blue theta or this angle was the angle I'm referring to. Now, I like teaching SOHCAHTOA. In my opinion, it is simpler, but law of sines, if you know how to use it, also applies here. However, law of sines is a lot more steps than SOHCAHTOA. Okay, so that is the parts of the triangle that we deal with the opposite, hypotenuse, and adjacent. So here are the equations that we use. So just like I wrote, and please make sure you write these down. So we basically take the sine of the angle equals opposite over hypotenuse. And so like all things in physics, it becomes a math equation. So if I'm trying to find, let's say I have the opposite side and I'm trying to find the hypotenuse and I have the angle. So I take the sine of the angle, and when you enter that into the calculator, make sure you do that separately. Like, do not put all the numbers in the parentheses. So you have to make sure in your calculator, if you're taking like the sine of 30, make sure you take the sine of 30 separately. Don't put like sine of 30 times something, because then you're doing sine for the whole thing. I'll show you what I mean in class. But so to move on, it is the sine of theta equals opposite over hypotenuse. And just like math, we can put a 1 over this, and then we can cross multiply. So if I'm trying to figure out the hypotenuse and I have the opposite, I can cross multiply and solve for these. So cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I'll show you an example in a moment. Now let's say that we need to find the angle, and we only have two sides, but we need to find the angle. Well, we can use the opposite function, and it's called the inverse function. And on your calculators, it's simply you hit the second button, and then you hit that same function. So, for example, if I want to find the angle and of the triangle, a certain angle, and I have the opposite side in the hypotenuse, I would simply hit second sine, and then I would put opposite divided by hypotenuse, hit enter, and that will give me the angle. Now, be careful, especially for those of you who are in pre-calc or calculus, because we deal with degrees in physics. We will always be in degrees. However, because of your math class, even Algebra 2 Trig, you'll be in radians. So when you're in here, you got to remember to put your calculator back into degrees, because if you don't have it in degrees, you'll get the wrong number. So once again, to find the angle, we look to see what sides we have, and then we look to see, okay, what function do I want to use? At this point, it might seem confusing, but you'll get used to it, because it's just a matter of looking to see what I have and then going to plug it into the calculator. So on the calculator, we hit the second button, and then the function should do its inverse. So for example, I have an example here where I have a 30-degree, you could hopefully see it's a 30, 60, 90 triangle. And I have, hopefully, give me a second, what side is this? Say it out loud. So hopefully you said I have, okay, so I have the opposite side, and the opposite equals 10 meters. I am looking for the hypotenuse. I can spell, I swear. Hypotenuse is such a hard word to spell. Anyways, hypotenuse equals x, and I have theta equal to 30 degrees. So what function do I want to use? I have opposite and I have hypotenuse, so if I go look at SOHCAHTOA, that's sine, because sine has opposite and hypotenuse, so that's what I want to find. So then I say, okay, the equation is sine of my angle equals my opposite side over my hypotenuse. So then I plug in, so I get sine of 30 equals, opposite was 10 over x, or you could draw hypotenuse, and at this point we cross multiply. So when we cross multiply, I get sine of 30 times x equals 10. Now it's multiplied, so I got to divide out the sine 30. Divide out the sine 30. And I forgot what sine 30 is off the top of my head. I think it's a half, but let's just check it. Yep, it's a half. So then I have x equals 10 divided by a half, which will equal 20 meters. So I know my hypotenuse is 20 meters. And that makes sense. Remember what I told you the other day. The hypotenuse always has to be greater than the leg. So 20 is definitely greater than 10, so most likely this problem is right. So this is the lesson on SOHCAHTOA. Definitely take your time with it and just make sure you understand the triangle stuff. Have a good one.